a question based on complex number. So for that it is given that mod of z square minus 1 is equal to mod of z the whole square plus 1, and we have to prove here that the z is purely imaginary. Now guys, what is meaning of purely imaginary? Purely imaginary is a number where real part does not exist. It means the value of z has to be only iy. So guys, let's start. So what I'll do is I'll start with the given condition. So in the condition it is given that mod of z square minus 1 is equal to mod of z the whole square plus 1. So let's put the values on left hand side as well as right hand side, and let's solve it to get the required result. So if I want to put the values on left hand side is mod of z square minus 1. So first of all I need to find out the value of z square, and for that I have to first assume the value of z. So let's assume z as x plus iy, and let's proceed for left hand side. So here I'll say z as x plus iy. So therefore z square becomes x plus iy the whole square, which is now in this expansion value of I square is minus 1. So we have seen it in the previous videos. So if I put I square as minus 1, this will become minus y square, and therefore that term will become real term. So I'll take all real terms together. So here we will get x square minus y square, that is real term, and the imaginary term is I into 2xy. So guys, here we got the value of z square. Now for left hand side I'll subtract 1 from it. So therefore z square minus 1 is equal to x square minus y square minus 1 plus I into 2xy. I'm subtracting that 1 from the real part because minus 1 is the real number. So I got the value of z square minus 1. Now let's find out the mod of that. So the mod of this number is nothing but square root of real part plus square of imaginary part. So that will become now guys, this is the value of left hand side. Similarly, let's find out the value of right hand side, which is mod z the whole square. Now what is value of mod z? So mod z is nothing but square root of x square plus y square, and in that we have to add 1. So here I'll say therefore mod z plus 1. Okay, so before adding 1 into that we have to square it. So here I'll say mod z square plus 1. So it is equal to square of this term is x square plus y square plus 1. So this is the value of right hand side. Now it is said that left hand side is equal to this right hand side, that is mod of z square minus 1 is equal to mod of z the whole square plus 1. So I'll put these values here. So we'll get therefore now I'm putting the values, so we will get this value in the left hand side and this value in the right hand side. So now after substituting the values, we will solve these two sides to prove that the z is purely imaginary. So guys, let's start. So to solve this, can you see square root on left hand side? So yes. So what we'll do is we'll find square on both sides so that the square root from the left hand side will be removed. So here I'll say squaring both sides. We'll get now guys, we'll solve this left hand side and right hand side and we'll cancel the similar terms. So now here I'm gonna use the formula of a minus b minus c the whole square, or let's see the right hand side first. Here we can use the formula of a plus b plus c the whole square. So guys, do you know that formula of a plus b plus c the whole square? I'll write for you. So a plus b plus c the whole square is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ac. So guys, we'll apply this formula on left hand side as well as on right hand side. So this will be x raised to 4 b square plus y raised to 4 plus c square, that is plus 1, then 2ab. So a is x square, b is minus y square, so that will become minus 2x square y square, 2bc, so that will become plus 2y square, and 2ac, so minus 2x square, plus the square of this will become 4x square y square, equal to, on the right hand side we'll get x raised to 4 plus y raised to 4 plus 1, and then plus 2 times x square y square plus 2 times y square plus 2 times x square. Now guys, let's cancel the similar terms. So I can cancel this x square with x square, y, x raised to 4 with x raised to 4, y raised to 4 with y raised to 4, then 1 with 1, we can cancel 2y square, and then we'll write down the remaining terms. So guys, here this minus 2x square y square plus 4x square y square will become plus 2x square y square, and then on the right hand side also we have plus 2x square y square. It means we can cancel those terms as well, so it will be cancelled. Now here we get minus 2x square on the left hand side and plus 2x square on right hand side. If I take it on the left hand side, that will become minus 4x square equal to 0. So therefore minus 4x square equal to 0, and if we solve this, then we'll get x equal to 0. So now guys, we are getting real part equal to 0. So let's come to the question. So here in the first statement we said let z equal to x plus iy. Now here we prove that x is 0, it means z is iy. So if z is equal to iy, it means z is having only imaginary term, therefore we'll say z is purely imaginary. So here we got the answer. Thank you very much.